Good evening, class. Tonight we're going to continue on with the roof drains that we talked about last class. Okay, so let's start with that page that we worked with last week, where I gave you some new problems to work out. Okay, now the first page, quite honestly, is pretty easy compared to the second page. The second page, not that hard, but you got to pay close attention or you can get lost on it. All right, so let's start with question number one. All right, question number one. Be sure you get your sheet out here. I should say, sure you got it up on your screen. Question number one is was 180 by 100, and we did that. That was a book problem, and we went through it on the board. The problem I gave you was the same problem, just with slightly different numbers. With different numbers, they weren't slightly different, and it was going to make for a larger roof. All right, now this roof was 285 by 195. And let's go through that. So what I did was to put the work right below the book answer for the previous problem. So right below where it says 180 times 100, I put 285 times 95, multiplied it out. It came up with 27,075. Okay, now because there were two roof drains, right? Now remember, these are vertical. These are not horizontal. These are straight down. Because these are two roof drains, we'll divide that by 2, just like the book problem that you have there. 18,000 divided by 2 was 9,000. Okay, in this case, it was 27,000, the new problem. 27,075 divided by 2, it came up to 13,537.5. We'll just lose that 0.5. So just round it to 13,537. You can go with 38 if you want, doesn't matter. Okay, so let's look that up. Now, what I did, if I remember it, I'm going to send you a chart, which you should have by the time you see this video. You should have the chart. And what you could do is, if you can print it out, you won't have to keep using your book for these problems. And you can also have the sheet that I use, which puts the vertical alongside the horizontal. It's just penned in on the left side. Makes it a lot easier. I don't have to keep flipping back and forth. I mentioned it to you last week. So let's take a look at that. We're looking for some vertical drains for 13,537 each. All right, so let's take a look. You could look on page 182. That's where the chart is, but like I said, I penned it in on 181. So we're looking for 13,537. Well, I didn't do this intentionally. It just happened to be a little too big for 6-inch, right? Just a little bit. So because it's a little over 13.5, we have to bump it up to 8-inch. All right, it came up just 37 square feet too small. Kind of a sneaky, that'd be like a test question, license question. They like to do that. So keep an eye on that when you're just a little bit over. Now, is there a chance the math is wrong here? It's possible, although I did it with a calculator. I think it should be correct. So in any case, 13,537 would be 8-inch pipe, right? It's a little too big for 6-inch. Okay, the next one, question number 2, is the same question number 1, but we're going to be looking for the horizontal drain on this. Okay, now a 1/4 inch to the foot. Now remember, I would, if I were you, I'd actually highlight this one. Most everything we work with is 1/4 inch to the foot. Storm drains can be 1/8 or half, right? But normally we work with 1/4 inch, and if I were you, I'd just highlight that center section there, because everything on these 2 pages that we're going to be working off is 1/4 inch. All right, so number 2, if you do the vertical and you're working off of, what was that, 8-inch, and you come down to the horizontal, what's that going to look like? So we're going to take the 1/4 inch on page 181, 1/4 inch slope column, and run down until we find something that can handle 13,000. What was that? 13,537. All right, it looks like it's going to be 8-inch. Okay, so we're coming down with 8 because we couldn't quite make the 6, and we go into 8, which is okay. You can never go from a larger pipe to a smaller. We already know that from our basic plumbing, right? And the vertical drains are normally smaller than the horizontal anyway, so you're not going to run into that problem. So in any case, answer for number 2 is going to be 10-inch. I'm sorry, excuse me, 8-inch. Okay, so the answer for number 2, the second half, would be 8-inch. Okay, now that's if we had, all right, I'm sorry, let's back up here. I forgot about the part where there's 2 roof drains. All right, my bad. Let's take a look at that again. The vertical drain, there were 2 of them at 13,537 a piece. They would come down to 8-inch, right? We had to kick it up that little because it went a little bit over the 6-inch. So 2 vertical drains, both of them are going to be 8-inch. Now, when you come down to the horizontal, if it was a single horizontal, in other words, the 2 drains tied into one line, okay, what would that be? Now, on the vertical, they only go up to 29,000. So take a look at that. 8-inch vertical is 29,000. Okay. Just by chance, this problem is just below that, right? It's 27,000. So we'll work off a 10-inch drain. So you'd have 2 8s coming down, and then once they join up, it would be a 10-inch line. Okay. Now, what would that look like? Let me show you this. Sorry if I confused anybody. I forgot it was a double 2 drain. Right, you got a roof, and your roof goes from here to here. These are the 2 drains. Now, as I said before, it was a little too big for 6, so we had to kick it up to 8. So we had 2 8s. We got 8, and we got an 8. And here's what we're looking for over here, this one. All right, so you add those 2 8s up. It would be like multiplying the 2 13,000, and it goes back up to the number you had in number 1, which was 27,075. All right. All right, so on the horizontal, take a look on the horizontal, and you'd have to go down to 10-inch. It just makes it. Okay? 29, excuse me. I said 27 and I wrote 20. Let's be this magic mark. All right, there it is. That's right. Okay, so you get 27,000 square feet for the whole roof. Cut it in half. We had the 13, just over 13,000. We had to go to 8. And now we're just going to make it with 10-inch here. Okay? Now I'm going to do this in red because we didn't talk about this yet, right? But this line here, until it joins up with this one, the only thing we've talked about is just what's the single drain over here, right? Either we've done the vertical drops individually, but we haven't done the horizontal drops where they all join in like this here. So let's just take this one alone. This pipe here was 8-inch. Remember, it didn't quite make it. It was 13.5 was 6-inch. We needed 13.5 and change, 13.537. 37 or 38. So we're just 38 square feet too small over here for this one to be 6. Now, what about this line? Well, let's see. If we have 1/4 inch pitch, we got 13,000 537 square feet. Let's run it down. Okay. It's going to be 16, right? It's going to be 8-inch. So this right here can be 8-inch. Okay? This one is 8. I'm going to make them both red. And this one is 8. Where they join up right here, okay, it's kind of an intersection, like a single lane, double lane. All right? So you got 13,000 and change, and it goes into here. So it was a 27,000. Okay? So this is 10. This is 8. So this would be what? A fitting. If this was a fitting right here, this was a Y. We haven't talked about fittings this size for regular plumbing, but if it was, this would be a 10 by 8 by 8, right? Y. Okay, some of you guys I'm sure have worked on roof drains on big buildings, and you maybe could elaborate a little bit on this here. Okay, I haven't done this stuff in many years. Okay, so that's where this all comes from. Now, not tonight, unless I get extra time. I don't think I will. We do have a problem on the next page, which has 4 of these coming down. We have to figure out the different piece, what it is at each stop where you have things joining up. It's kind of like the gas shot, right? Where you telescope it down. This one is the same thing. You actually telescope down to the last drain. Works the same way as the gas. Okay, that was number 2. Question number 3. Remember, question number 1 and 2, just like the one we did last week, was just part of the same problem. They just split it in half. Question number 3. And if you notice to the left side, it has V or H. And I'm not sure if I spelled it out, but V is vertical and H is horizontal. Just so I wouldn't get mixed up on them years ago when I did this. If there was a roof drain that was 260 square feet by 80 square feet, all right, we did this last week. We went through the question, and you can see it. The book answer is right below there, right? It came out to 5-inch pipe once you divided it by 3. So it was 20,800 divided by 3, 6,933. And 6,933, let me get that page out, on a vertical is 5-inch pipe. The 4-inch is just too small. Okay, we already did that. If you got a question, ask, okay? Unfortunately, I can't talk here right now, but seriously, when we go live, keep it in mind. All right, so tonight's question was, which I gave you before for an assignment, was if the roof size was changed to 295 by 115, same 3 roof drains, what size would the rain leaders be? As soon as you see leader, that's like downspout, right? That's vertical. And if there's any doubt, look to see if there's pitch involved. If there's any pitch, it's absolutely horizontal. Can't be anything but. In this case, I don't see any pitch. All right, we're looking at vertical. So that's page 182. But if you want to stay with 181 like I showed you, and remember that. And I think, like I said, as long as I remember it, I don't know how close I can get with this, but I just put the vertical measurements over here from the other page. Okay. So we divided by 3. We ended up with 5-inch pipe. All right, the new problem, 295 times 115, I came up with 33,925. It's more than 50% bigger, so it's quite a bit bigger. And then you divide it by 2, and you come up with 11,308. Okay, it's a lot bigger than the original problem. All right, what size pipes are we looking at? 11,308 on the vertical chart on page 182, or if you penned it in, 181. It's going to be 6-inch, because 6-inch can handle up to 13,500 square feet. All right, so we went from 5-inch pipe to 6-inch pipe. All right, so the new problem is 6-inch pipe. Okay. Number 4, same problem. Again, they split it in half. Now that storm drain using 1/4 inch pitch, right, would be what? Now here, they're just looking for a single pipe. In other words, remember this one here? If we had a third one here, we wouldn't pay any attention to the sizes that would be increasing, or actually decreasing going that way. All right, they're just looking for this one right here. That's it. All right. So what would that be where all of this stuff joined in? And what they're telling us is that using the 1/4 inch chart, and we're working with the 33,925. All right, let's look at the horizontal chart, 1/4 inch. Read down until you see something that can handle 20. What was that? 20. I'm sorry, 33,925. Okay, 10 inches is not big enough. It only goes to 29. You got to drop down to 12. All right, so it's a 12-inch drain right here, which is enormous. I mean, it's bigger than any problem that we have here. But obviously, there's roofs that size. So looking on the chart, we have to drop down to 47,000. Read left, and you're looking at 12-inch. Okay, so the answer for the problem is 12-inch. Okay, so number 4, write it down, 12-inch pipe. Now, the 10-inch, which was the answer for last week, for the book problem, you can tell it's 10-inch because if you cut it in half or cut it in thirds, obviously it wouldn't be 10-inch. So they're not looking for the different places. They're just looking for when everything joins up. After the 3 of them join, what is it here? Okay, that was number 4. Number 5, new problem. Now this is a new size roof, 165 by 130. This is that cute one where they cut a piece of the roof out. In real life, what they would do is have this problem very, very close to 2 different sizes. So if you messed up on cutting that little piece of roof out, you get the wrong answer. I'm sure that's how it would be done. All right, the book problem we did last week was 165 times 130. Now you can see it there, and it comes up to 21,450. Now they're not looking for any drains; they're just looking for an area. I extended it to add the drains in, so that comes up to 21,450. And that little piece that they cut out, like an entranceway or something, well, it wouldn't even be a courtyard; it'd barely be an entrance. Is 25 by 17, and it would come out to 4.25. All right, so you deduct 4.25 from 21,450. Again, I'm reading it off last week's problem, and the answer was 21,025 square feet. End of problem. Now, what I did was to add to that. If you had a vertical pipe, a single vertical pipe coming down, right, from this roof, what would it be? Okay, let's take a look on vertical pipe. Remember, that's 182, or if you penned it in, it's 181. Vertical pipe, we need 21,000. Let's see, 13,000 is 6-inch, 29,000 is the 8-inch. Right? So we have to kick it up to 8-inch pipe. So the answer for the original one was 8-inch pipe. That was the book problem. All right, now I gave you a new roof size. All right, it was 230 by 130. All right, 230 by 130 comes up to 29,900. Now remember what I said. These aren't book problems. These are the ones that I did. I could have made a mistake. So if you get a different answer, it's not necessarily wrong. We'll talk about it, okay? Obviously, I don't want to be putting out wrong answers. But I'm pretty sure this one is correct. So 29,900 minus 425, the same 4.25, I didn't change that, comes up to 29,475 square feet. Okay, 29,475 square feet. Surprise, I went right off the chart. I didn't know that when I gave you the problem, but it's okay because it's a little bit too big for the 29,000. We're just over, right? We're over by 475 square feet, which is almost nothing. However, according to this, you still have to kick it up to the next size. And the next size would be 10 10 inch. It's not on the chart on page 182. That's why I didn't pen it in, but obviously that would be the next size up. So for this new problem, problem number 5, right? The answer was 29,475 square feet, right? And if you look that up on the chart, it goes off the chart, and you just obviously just pick the next size up on the vertical, which is 10 inch on the vertical, right? Just a little bit over. I imagine 10 inch would go up to, who knows what, maybe 40, I think probably 40 some thousand, right? As you can see, from 6 to 8, it almost doubles. Actually, it does, it more than doubles. So 10 inch would probably be more like 50, 60, but we're not worried about that. Okay, so the answer for the new number 5, 230 by 130 roof would be 10 inch pipe. Okay, now let me double check my time here. All right, we've got a bit of time. So what I'm going to do is I'm going to ease into the next sheet that I have, which is a little bit more advanced than this one that we're leaving. Okay, this one is good in a way because it's going to be a review for what we've done in the past with the math. Now, according to your, I guess you call it your syllabus for the year, tier 1 and 2, they're close, but there's a lot of math for both, and this is something we already covered. Area of a circle. Now, do we use areas of a circle out in real life? I don't even think so. Not that I ever did. However, that doesn't mean you're not going to see a question for your exam. You're not going to see a question. So let's do a quick review on area of a circle. All right. I'm not even going to bother with pi r square. You want to do pi r square because that's what you learned as a kid and you remembered it. You're comfortable with it. Knock yourself out. This one is easier without a calculator. But with the calculators, really the formula is up to you because you just punch it in some numbers and the time it takes is pretty much the same. I like this new one. It was something I didn't learn until I think I already have my license. This problem here, how to do this, something other than pi r square. All right, so let's take a circle. We're going to take let's say just a 6-inch pipe. Not even close to round, is it? All right, a little better. Okay, so we got 6 inches across. Okay, what is that? It's called diameter, right? D. Now, let's take from the center right here to here. What's that? It's called a radius, which is 3. Okay, radius is always half the diameter, right? And another one, I'm going to make this quick because it's not part of the problem. From here around and back to here is called the circumference, and that's that pi. Remember that 3.14? Sure, that sounds familiar from your school days. Okay, and that would be kind of like, I always think of it like a piece of smoke pipe. So you get a piece of 6-inch smoke pipe for a boiler. Open up the smoke pipe. And if you multiply the 6-inch times 3.14, you come up with, I think it's 1850 something. That's what it would open up to, like this. Okay. Do we use it? Not really. I remember opening up a piece of smoke pipe a few times to get a piece of smoke pipe through like a one of those walls in an old tenement house where they have just boards up and you got to get through it without getting too close to the wood because you use a single regular smoke pipe, right? Single wall vent connector is a proper name for it. Okay, but anyway, this here is what we're starting with. Now, the area of a 6-inch square, like this, would be area equals diameter squared times 0.7854. Okay, so this one was 36, 6 times 6 times 7854. All right, A equals. Now I'm gonna have to do this quick on the calculators. I think it's 28.52, something like that. But what it's saying is this. This would be like if you draw the square over this, what do these corners add up to? Right? That's how you get, that's what this is. So if you draw the circle in the middle, the circle is 78.54% of a square. That's all it is. Right? That never changes. So a circle is 78.5% of the square that would like go right over this. All right. This problem here, I think, is easier doing it this way. Right? Diameter is easy, 6 times 6. And let's see what we got. So we got 36 times 0.7854 equals, 28.27 square inches. Okay? So that would be, just a basic math problem, starting with a 6-inch diameter or 3-inch radius. Right? Now, let's transfer that to a roof. First of all, how many of you guys have seen a round roof? Yeah, neither have I. I think there was an ice cream place once in Somerset. Might have had, I think it had a round roof on it many years ago. But a commercial or even a private home, where do you see a round roof? All right. In any case, you still have to know how to do the math for this. So, number 6, area 56. One side to the other, 56 feet. So this would be area equals diameter squared times 0.7854. All right. And, okay, they're giving us this one, so I'm just going to take it right off the answer sheet here. Okay, so let's do 56 times 56 first. All right, 56 times 56 equals 3,136. Okay, skip that 56 squared right here, but I think you can see that. All right, so that's what we got if it was a square roof, right? Perfect square. But we got to multiply it by 0.7854, 78.5%. Okay? 78.5%, remember, represents the 4 corners cut off of this roof. All right, if you multiply this out, the roof area drops down to 2016. Right, I think you all agree that's a pretty small roof for a commercial building. That's more like the roof size off a house. Okay, that's a good size house, but still house size roof. Now, they didn't ask, but take a look at that for a minute. What size, if you had one drain right in the middle, making it really easy. Obviously, it'd be easy to pitch it in, it'd be like a shower drain. What kind of vertical drain are we talking about? Now, this is much smaller than any of the problems that we've worked on so far. Let's take a peek. Okay, 2,100, 2,000. That could actually be a 3-inch pipe. That looks pretty small. If now this is not our concern. If it was part of a contract where we had to run, they wanted us to run the roof drain to wherever they had, wherever it's supposed to go. That's fine. but we wouldn't be designing a roof like this. The only time you do this is for your license. Okay, but according to this, a 3-inch pipe would make it. 2200, kind of close, but it would make it. And I think you all agree, something like this that could just like flood over the sides, maybe that wouldn't be such a great idea. You probably want to put a couple of drains up here, or at least go oversize on it. But the right answer is 2016, and this would be 3-inch pipe, right? Which is not what they asked here in the problem. Okay, now once you go horizontally, let's say that 3-inch went down and you hung a left or a right, what would it do? Well, let's go to the horizontal. 1/4 inch horizontal. Let's see. That would be now 3 inches is too small. Only does 1100. So you'd have to kick the pipe. Let's see. The drain came down like this. This would be 3, and this would be 4. Okay. Well, it looks awfully small, but according to the chart, that's how it works. The 4-inch is adequate. It goes up to 2650 on the horizontal. All right. Now, I didn't ask for that. Just want to show you how it would have been done had they asked for it, the book or your exam. Okay, now the problem I gave you was 75 feet. And I think I am running out of time. 120. A few more minutes. All right, see if I can finish this one up. All right, so we're looking at 75-foot roof. So let's get rid of this. And this here. All right, let's do this one quick. So this is 75. A little bigger building. All right, so A equals 75 squared times 0.7854. 75. Let's see what we got with 75 times 75 equals 5,625. Okay, if it was a square roof, that's how big it would be. So if you squared this off, it should come up to this. Okay, now we got to multiply it by a little more than 3/4, 0.785. So A equals looks like 4417. Let's make sure that's what I got. Okay, hold on. I don't have this one here. 4417. Okay. And if you did it, you could tell me what you came up with for the vertical. Let's take a look. So a roof that size would need 4417. Actually, 4600 is 4-inch. So the drop coming down on this new roof would be 4. That's a little bigger. I'm curious, what is this going to be on the horizontal? Again, I don't know that you guys did this, but if you did take it this far, on the horizontal 1/4-inch pitch, it's 44,175. All right, it looks like 5-inch will do it. 5-inch will do up to 47. We only need 44. So it would look like that, right? Almost always you're going to find this one is smaller than this one because the horizontal can't handle the capacity of a straight free fall. Okay, that was number 6. All right, I'm going to stop this one, and I'm going to pick it up, like they say, on the other side.